Hello there, Cardinals. It's me, Mr. Ernst, and today we're going to be learning how to find the volume of cylinders, cones, and spheres. And the reason we're learning these three all together is because all three of them are based off of circles. That's not a circle. That actually kind of looks like a pumpkin. But all three of these are based off of circles, okay? We're going to be learning about these volumes from a volume we're already familiar with, which is the volume of a rectangular prism. And we're going to kind of see how those guys are related to one another, okay? The first thing I want to say is that this is not an ellipse and this is not a parallelogram. This is a rectangle and this is a circle. They're just kind of laying on a flat surface here as though they're sitting kind of like on top of a desk type of thing, okay? So these are just laying flat on the surface. So the first thing we need to know is that we have, for the rectangle, we have length and we have width. And the area of this rectangle is length times length multiplied by width. For our circle, we have a radius. And the area of a circle is going to be pi r squared, or pi multiplied by the radius squared. However, we're not dealing with just two-dimensional shapes today. We are actually dealing with three-dimensional shapes today. So we need to bring in one more dimension for the circle and the rectangle. Boop. Just like that. So from here, our new dimension for we got this one here. Doot to doot. Doot to doot, and doot to doot. And that's going to be our height. And on this side as well, bop and bop. So now I have two three-dimensional shapes. A rectangular prism and a cylinder. Now, because we brought in this extra height, all we have to do to find volume is to multiply this height by the original area. So to find this, we have length times width times height. And for this over here, we have pi r squared times height. So the volume of a cylinder is going to be the circle. A circle multiplied by height gives us a cylinder. Likewise on this side, a rectangle and a rectangular prism. 2D versus 3D. So that is our first one. The volume of a cylinder is going to be pi r squared multiplied by height. Now we got to look at a cone. And both a cone is going to be similar to finding a pyramid. Essentially, we got to find a center point here, and that's kind of the top of our shapes. We got 1, 2, 3, 4. And on this one, a small dot in the very center. 1 and 2. So now we have a pyramid in the center of this, and we have a cone in the center of this cylinder. So how do we get to these shapes? Well, it is not the entire rectangular prism. We're actually shaving off all of this stuff. That is not the pyramid itself. It's all getting kind of shaved off. So we need to take 1/3 of the original rectangular prism. So we're going to multiply it by 1/3. Now I want to say that this is the same as being divided by 3, but I'm writing it out this way so you can kind of see the gradual steps of what each of these look like. Okay? So a pyramid is length times width times height times 1/3. And a cone, likewise, is going to be pi r squared, a circle, times height to make a cylinder, and also times 1/3 to make a cone. And again, it's because we're shaving off all of this stuff that is not the cone. This is us removing all of that excess cylinder that we don't need to get to our cone. Cool? So now we have the formula for our cone as well. In fact, I think that's actually going to vanish here in just a second. And again, I want to emphasize, this started circle, cylinder, and now cone. 3 steps. Cool? So that's where we have the volume of a cone. And now we have to take a look at the volume of a sphere. Let's see. Now, spheres are a little bit weird, but remember, there is nothing to fear but sphere itself. So a sphere actually comes from a sphere comes from a cylinder the same way that a cone does. So remember, a cone was kind of like, we kind of carved it out in the center here and everything like that. A cone or a sphere is basically the same type of thing. So once again, we're going to start off with our pi r squared multiplied by height. That's our cylinder. And then the last step, instead of multiplying by 1/3, we have to get rid of all of this extra stuff here, which isn't actually as much as the cone. So we're actually going to be doing 2/3. And that is the volume of a sphere. Pi r squared times height times 2/3. Now, something that I want to mention here is about the height. Height is not as clear as it would be with, like, say, a cone or for the cylinder. Because it's a ball. Like, how do you measure the height of a ball? I mean, you're going to go from here, the top of the ball, all the way down to the bottom of the ball. So something I want you to keep in mind is you are not going to be given the height of a ball, but what I want you to remember is that this, from the middle to the top, is a radius, and from the middle of the sphere down to the bottom is also a radius. So the height is actually going to be 2 radiuses. So just keep that in mind when you're doing it. Remember that when you're doing this problem, it's only going to say like r is equal to 2. You just got to keep in mind that height is going to be the diameter of this, or 2r. Cool? So, in review of this, a cylinder, we start off with a circle. Let me grab the right layer here. There we go. What is... oh, that's why. And bow. So once again, we start off with a circle, which is just pi r squared. Then we get to a cylinder. This is going to start looking really messy. A cylinder is pi r squared multiplied by height. And then it kind of breaks off. It branches off into one of 2 things. The first one it can be is a cone. It's going to have the circle bottom, and then it's going to have the pointed top. And this is going to be pi r squared times height to make it a cylinder times 1/3 to make it a cone. Or it's going to make a sphere, and these are looking really bad, but so I apologize for that, which is going to be a circle turned into a cylinder and then multiplied by 2/3. Okay? So once again, for all 3 of these, from the top, cylinder is pi r squared times height, a circle times height. A cone is a cylinder times 1/3, and a sphere is a cylinder times 2/3. So 1/3 and 2/3. And that is the volume of cylinders, cones, and spheres. The last thing I want to say is that if you were to look these things up online, these are going to look very, very different. For example, this one is probably going to look something like h pi r squared divided by 3. And then this one down here is going to look really weird to you. It's going to look like 4 multiplied by pi r cubed divided by 3. And I want to say that this and this can be used. They are the exact same thing, but the reason, again, why I wrote this out, I really want you to understand why, how these things work. It starts with a circle, it turns into a cylinder, then we shave down the cylinder to get the sphere. And the same thing with the cone. We start with a circle, we turn it into a cylinder, and then we shave it down to make a cone. So all three of these are very closely related, which is why I wrote the equations out like this, because it can help you remember where these things come from, okay? And that is the volume of cylinders, cones, and spheres. Thanks for watching.